Welcome everyone. This is our weekly API work group meeting. So for today's topic, I think we have it set up to discuss Kubernetes and K8's functionality. I think Vipin, you had something that you wanted to bring forward on that.
Yes, certainly, Mark. And these are just thoughts. Definitely encourage everyone to. Let me pull up the slides. Give me a second.
Yeah, I think it's important that we figure this one out because there's two trains of thoughts around the APIs. One of them is, how do we do functions and services that are offloaded onto DPU, IPU platforms. And then of course, the other half of this is how do we do it where you have a controller that sits outside and it's going to direct and manage and control the system. So this leveraging the Kubernetes kind of covers to some extent both, and then how we tie into that. So
yeah. Definitely, I think the good and bad part of Kubernetes is there are so many choices we have. So either we can leave it to individual situations to figure itself out and see what prevails, or we can take a stance and work towards something.
Correct.
Mark, and on previous call, I think Erwan and Christoph also wanted to present, or this is going to be today? No. Christoph, you're on mute still. You're double muted.
No, we can't hear you still.
We see your video, we see you talking, but we can't hear.
Zoom seems you unmuted, so is there a double mute somewhere?
Hopefully this will be better.
Yes. There we go.
Thank you. Okay, so yes, indeed, I do have just a simple slide in order to present what I have in mind in order to present that. So I will try to share my screen because it will be much better.
Okay, go ahead.
And of course, it seems that I don't have the ability to share my screen.
Hold on. All participants is set up.
So I joined with the web browser and not with the Zoom application.
Oh, okay.
Sorry for that.
It might be the web browser aspect of it.
Yeah, I'm so used to Google Meet that
you want to export a PDF and then show us from the PDF, or maybe you can pass to Erwan. He can present.
I can share. Perhaps I can share if you want, Christoph.
Yes, that would be great, Erwan.
So, okay, I've got it. If I try to share my screen, now it's here. Did it work?
Oh, perfect. Thank you.
There we go.
Maybe on the next one. Yeah, perfect. So the main idea about that is to have and to migrate to something like a network intent-based API rather than pushing specific RPC calls in order to program what is inside the DPU. So that's why I'm actually trying to push for NetOpera or, well, with the netconf, so that with the proper YANG models that we are still working on it in order to have the working on some kind of POC, that would allow us really to expose the network intent from both the network administrator perspective as well as the proper workload perspective. So the idea would be to have, as a first version, the basic functionality exposed as YANG models. So I think everyone is pretty much aware of what YANG models can do. So we already talked about OpenConfig, but we are also looking at the other base YANG models, so based on the IETF, because it seems to be much more featureful, including NAT, including additional elements as well. So the actual Young model, honestly, from my perspective, whether we go with OpenConfig or IETF right now may not be relevant. I'm much more focused on the decoupling between the workload and the DPU. Because as soon
So
as
Christoph, in this picture, when you
Yeah.
talk about decoupling, can you just point out what the components we see here and what is provided by whom? Where the API abstraction can come, what is OPI can do, what is OpenShift domain expertise, what is the hardware abstractions here? So just maybe a color code.
Yes. So if we go with with a unique OpenShift cluster running on all DPUs, we would expose a netconf resconf API so that with that netconf resconf API, the network administrator will be able to provide the network policy, for instance, to allow which VLANs, to allow which tunnel, and so on and so forth, so that for bare metal use case, that port attachment is not even required because we would provide a physical function or virtual function that would be completely controlled by the network administrator. In the case of running a workload on the x86 hosts, that's where we, with a specific CNI or ML2 plugin, so for OpenShift and OpenStack, we will have that specific port attachment request. Still, we will go through exactly the same API that will be exposed by OPI, of course, but that would be netconf or resconf. And thanks to the RBAC built-in netconf, so with the sysrepo and the IETF ACM, we will be able to limit the capabilities that are exposed to the OpenShift or OpenStack. So that would be the basic functionality. So Erwan, if you can move to the slide, to the next slide. Yep. So why I'm actually pushing for that, that's because when a CNF operator will deploy that a specific CNF on the DPU, and Erwan, if you can just click once again. Thank you. That CNF operator with the standard sROV device plugin could also plug and make available a specific accelerator to that CNF. So that's completely internal to the DPU and it works as usual. But at the same time, it will be able to inject a specific Young model into sysrepo or to any Young database so that we can expose that additional functionality towards both the network administrator as well as to the x86 host. If we think about a DPI application, we could expose those configurations to both the network administrator and to OpenShift. And on the last element, Erwan, if you can just click again. Thank you. If we think about Istio service mesh, or if we any kind of network policy, because it is actually enforced by the network administrator, we can create a specific service chain that could be completely hidden by the x86 host, or eventually, once again, if the configuration is exposed to this repo, we could even provide additional tunables to OpenShift and OpenStack. The only interface, of course, would be that NetOP or netconf resconf interface.
A couple of questions. First of all, on the left, you show network policies and configuration, goes to NetPeer 2. What is this interface going to be?
That's also netconf. NetOPER is a netconf repo tied to sysrepo.
Okay. And another question, in this proposal, the CNI ML2 on the top is going to implement and use netconf resconf to configure. And this is what you propose to be OPI standard. Does it mean that other CNI providers will have to implement exactly the same netconf resconf in addition to OpenShift? We want to work with Calico, for example, and others. They will use, the proposal is they will all use the same netconf resconf interface?
Yes, because on the Calico side, that would be located within the DPU. And so on the OPI side, well, from the x86 perspective, whether we are actually running on top of Calico, Oven, or any other elements, that would be completely transparent for them. because the only thing they request is a configuration of a specific virtual function or scalable function. And that network request will be completely transparent because it's an SIOV device. I just want to have that VF connected to that pod attached to that network.
Another question on the CNF XYZ. This is something, for example, in this use case, implemented and provided by OpenShift?
Well, yes, and that CNF shall be deployed by OpenShift, indeed, from the DPU cluster.
So that means that you will have a separate implementation of CNF per DPU vendor, right? Because I see here that CNF is going to talk to specific accelerator XYZ. So if accelerator is implemented in another way, so CNF XYZ would be different on NVIDIA, Marvell, AMD Pensando, and others, correct?
Well, it depends, because either we do have a common young model for DPI, let's say for that. And so on the exposed young model, we will have a common API. And eventually a specific CNF vendor, so let's go with F5. They could go with either the standard IETF young model for load balancer, and they may want to have their own proprietary extensions.
So the question is, if there is an abstraction between CNF XYZ and accelerator XYZ is also needed here. And if this is in scope or out of scope of OPI. Because so far, I understand the northbound.
From my perspective, that's out of the scope of OPI because that's internal to the DPU. Within the DPU, and from OPI perspective, my understanding is that we should really care about the external interfaces and what is actually running within the DPU. In our case, we of course want to push for OpenShift. And so we will leverage the CNF operator and so on and so forth in order to use the SIOV device plugin so that internal accelerator will be connected to the CNF pod. But maybe it's not SIOV inside because on Marvell or NXP device, we don't have that internal PCI bus in order to connect that. Maybe it's another bus. So we need a different operator to connect that accelerator to that CNF. That should be completely internal to the DPU. Yet, for the x86 host, what we should really care about is only the young models that will be exposed so that we can leverage and have a continuity between also different hardware vendors.
Christopher, I have a question. So I like this idea. I think overall, we are asking CNI vendors and CNI providers to align with the model that is exposed through NetConf. Ultimately use that as a way to talk to DPU, and therefore all DPU vendors could implement this API, and how they use it underneath, whether vSwitch or Oven or VPP or P4 is really left up to them and their capabilities and what they are really good at, and leave that out. However, is that understanding correct?
Yes, absolutely.
Yeah. Okay, awesome. So given that, I was also struggling with this question. If CNI vendors are really going to be, this would be effectively creating a different CNI. And the reason I say that is because every CNI has a way of implementing its own data path and all that. So, so therefore, I think, it is quite possible that, like, for example, if you're trying to fit that into how southbound OPI of Oven controller looks like towards the node or towards the OVS DB host, that may not look like the NetConf RESTConf API that we are seeing, for example, here. So, or if we were to leverage Calico plugin APIs to try and leverage data paths from there, then I don't know whether RESTConf, NetConf will align with that. In other words, what I'm trying, and same thing with Cilium. So I'm taking these three CNIs primary, but there may be more CNIs than these three. But let's take these three CNIs. Do you think the NetConf, RESTConf API is going to align with these CNIs, or do you think that this is a completely different CNI, which really is a very simple VF to pod association, and then use RESTConf, NetConf to configure Kubernetes functions such as network policies and load balancing and all that to rest in NetConf.
Well, as you expressed, we already do have multiple CNIs with different capabilities.
Yeah.
So if we can settle on an extension of the SROV operator of the SROV CNI, this will allow us to have the basic functionality that will be available across all vendors. But indeed, at the end of the day, we will want to leverage the additional capabilities of each specific implementation of that DPU. And that's where, at some point, we will want to extend that CNI with additional labels, with additional configuration, with specific options that could be pushed through that very same CNI.
But what makes you think, Christoph, that CNIs are going to adopt the NetConf RESTconf that you show here? Today, they already have their own interfaces and implementation for servers outside of DPUs. What makes you think they will adopt the NetConf RESTconf model?
Well, because that CNI will still be relevant within the DPU. And then we need a shim layer that will be exposed. Yes?
So how much of this proposal depends upon NetConf and RESTconf as configuration transport protocols? And how much depends on the fact that you're going to expose a set of Yang models for configuring CNIs, independent of how you access those Yang models?
Say that again, I may not get you.
So you have NetConf and RESTconf prominently on here. Does this approach depend upon NetConf and RESTconf as the configuration transport protocol? Or does it depend on the fact that you want to define a set of Yang models that map the CNI configuration? And then there's a different discussion about how to access those Yang models. In other words, how to do the sets and get those Yang models.
Well, I really wish to move forward with both options. The first one is to go with NetConf with a predefined set of IETF models, Yang models. And why? That's because I'm pretty sure that we already have a lot of utilities in order to configure the top-of-rack switches through NetConf RESTconf. And from the network policy and from the network administrator perspective, enabling that and exposing NetConf with the standard Yang models, this will allow every single network administrator to control both the top-of-rack switch and top-of-rack routers, as well as the DPUs in a single management layer.
Okay,
well, so that's why I'm pushing for both of them.
Okay, okay. The second question is what set of Yang models? Because quote standard IETF Yang models, you know, there are about, I don't know, 100 of them, and they don't necessarily all work together. I mean, there's subsets that work together, but they don't work together very well. So what every vendor who's ever implemented those has done is they've built a proprietary superset and extended them and changed them so that essentially every vendor writes its own full set, and IETF doesn't really standardize, which is why, of course, OpenConfig was created to standardize the Yang models for a complete set for network configuration. And IETF tried a few times to unify and they failed.
Well, that's true that if you look at current implementations, they may have 3 different implementations, and the current some of the vendors implement all 3 of them. So the OpenConfig model, the IETF model, and the specific Yang model, which is proprietary.
Well, so again, so there are people who do OpenConfig pretty much straight, and there are people who do adaptations of subsets of the models that are defined in RFCs. I wouldn't say that IETF has a consistent, coherent model. That at least the last time I checked, which admittedly was about a year ago, they had still failed to put it all together in a complete. Here's what a switch is, right? So there's the interface model and the VLAN model and the I could bring up my diagrams that show all that because we looked at this. So with Redfish, we looked at this, and Redfish for networking finally said, we just need to say, go use the open config models, and here's the mapping of Redfish to Yang, right? So the Redfish language to Yang, here's how you map between the two, and we wrote a generator for it. But we punted on trying to make a consistent set out of the IETF models. Now, if there's a subset that you've identified that would say, if you implement the subset, and again, find netconf, then that's how it maps to CNI. That would be sort of interesting and cool.
Before we jump into implementation, I think I have a few more generic questions, if you don't mind, Chris. So what you're saying is basically, if you do netconf, for example, and we can switch to something else, but let's roll with this example. It will help network administrator to treat DPUs as top of the rack switches and stuff like that. So whether they're already using, I don't know, like Ansible automation or whatever, they can use exactly the same tools to configure DPUs. So this is what you're saying.
Yes.
I can absolutely relate and understand that. What I'm missing is one use case is, okay, you're running your OpenShift inside the DPUs. Okay, that's fine.
Mhm.
What happens if you're going to run now another Kubernetes on x86 host? Can be also OpenShift. Then how that CNI of OpenShift is going to talk to the OpenShift inside the DPUs? Is it going to use exactly the same netconf restconf configuration?
That's exactly what I hope, yes.
So
With a
that
specific
brings out the big question that
Hey.
Vipin asked, how then you can assure that other CNI vendors
If you don't mind, I would like to share some configuration that various CNIs expose along with this. So let's stick to this conversation, but in this context of what is going to come through the netconf restconf layer. And some of these CNIs are like 4 or 5 years old, and people have deployed it, and there's brownfield situation, and asking those CNIs which are strengthening their message and saying you can use the same CNI on-prem, off-prem, on cloud, and all kinds of things is a question that we cannot answer unless some CNI vendor comes and say that they are willing to take this API. But I want to give a glimpse of what APIs are exposed through the CNIs today that are shipping features, like, and vis-a-vis netconf and restconf, which is primarily open config configuration, which is primarily driven to configure switches, versus the CNI configuration. Of course, none of the CNIs adopted open config for their interface, but I don't mean to say just to configure from the logistical point of view of calling the APIs, but the heart of the APIs and the content of those objects, that also doesn't match with the open config Yang model. And rightfully so, because I think one is configuring a network switch, other one is trying to configure pods and the networking for those things. And anyway, I think I just want to highlight, if you don't mind, one slide that describes what object various CNIs offer with references.
So before we do that, Vipin, can we go back to Joe's question? I don't think he got it answered. So Joe, you want to ask your question again?
Yes. Well, so it's actually Vipin phrased it a different way, which is what is the set of Yang models and what do they control in the CNI? This kind of controller structure and transports a separate interesting question. And then a third question is the one Boris was asking, which is the use case stuff and whether people would adopt it and so on. But understanding how the models map to control the CNI and how that would apply to the DPU directly, I think is useful. And that's what and that's also part of what Vipin was just asking as well in a different way.
Okay, just want to make sure we got yours covered too. Okay, go ahead, Vipin, sorry.
Yeah, Chris, let's keep this particular picture in mind. And in this same context, I would like to share some reference to various models that are there. If you can allow me to share. Okay, awesome. So, so I think the main question that I have in this slide really is, do we develop a CNI that is different from existing CNIs? I think we can bring the DPU value greatly. I don't doubt it. I'm 100% convinced that if we are allowed to have a SRIOE based CNI that could really give the best of the best performance and best of the best feature sets, we could have a CNI that is, and from all DPU vendors, we all can come up with a definition of CNI and say, hey, as DPU vendors, this is our CNI. If you want to take advantage of DPUs, use the CNI, and you'll be flying with all the performance you ever need from any DPU. So because we could optimize it towards that. Having said that, most of the CNIs have these objects that are looking like following, like, this top part is the commonly defined object from Kubernetes itself. So CNI is also listening to these Kubernetes objects. Besides plumbing the VF into the pod, there is also a functionality where it needs to listen to endpoints, it needs to listen to service objects and network policy and all that, and then effectively translate that. Running that on CARD is okay. I definitely don't think it's a bad idea per se, but then CARD needs to have access to API server to be able to fetch all these things and all. There needs to be still some entity that is running on the host, and we can call that, DPU CNI or some SRIOV plus CNI, maybe. Let's call that. But is it Calico? Is it Cilium? Is it OpenShift SDN? I seriously doubt it. The reason is following. I mean, if I look at, for example, Cilium, I mean, it exposes APIs that goes beyond Kubernetes objects and defines an enhanced multi-site network policy, for example, or it defines the way to mirror traffic across the network. And this is different for different CNIs. And I'm not saying that, one is better than the other. It's just that they have different ways of doing these things. And some exposes BGP as a way to do routing. Some exposes plain simple route tables. Some exposes network as a first-class object. Some are like, that is not the responsibility of the thing. Now, if you map it into OpenConfig, network is a primary citizen. I mean, you can't do anything without defining a subnet or a network. Whereas Kubernetes, if you look at the Kubernetes base set, there's no definition of network. It's just that pod is assigned an IP and that's it. And after that, I think, it starts to really show up in the network, and CNI is supposed to provide the connectivity to this IP somehow through the Kubernetes cluster. So my question really comes down to the heart of this thing. I don't think what you're proposing is a bad idea, Chris. It's just that, if we all as DP vendors agree that we need to create a SRIOV plus CNI to bring the power of DPUs, I'm all in for it. But I don't want to confuse that with leveraging any of these references that I put here. And if you look at any of these, Oven, for example, northbound and southbound APIs, or Calico plugin APIs, or not OpenShift uses Oven, so let's say, or Cilium APIs, to be confused with OpenConfig APIs, because those are to configure a switch, and these guys will likely not align with that. And asking them to change it is pretty much asking them to redo something from a fundamental level. That's my feeling. But we can convince them. If we want to convince them, let's go that route and say, guys, DPUs, this is the best way to take advantage of it. Otherwise, we have to look at accelerating some of the things that already exist. So I'll stop here.
I fully get what you're saying, Vipin, because the main idea and the main difference between OpenStack and OpenShift is that on OpenStack, you are completely L2-centric, whereas on OpenShift, you are service-centric. You are not even L3-centric. You just want to get some connectivity to your pod. And that's why I really want to push forward towards the network based and the network based intent. Intent-based networking, sorry. And
so if you... No, go ahead, please. Sorry, go ahead. Yeah.
The idea is that from an OpenShift perspective, what do you want? Do you want to have connectivity, or do you want to configure your L7 load balancer? So what you want at the end of the day is basically to have that specific connectivity within your pod. And then how it is interconnected, it has to be the responsibility of the network administrator, so that same Calico API and so on and so forth should be deployed only on the DPU. And that should be a detail of implementation from the OpenShift end user and OpenShift developer. So that the OpenShift developer will only care about that end connectivity and what's happening below, whether that's enabled by a service mesh, by Calico, by BGP, and so on and so forth. It shouldn't care about that. So all those endpoints and all those constructs will be also exposed through that Yang model. because with that Yang model, you will only want to request one specific IP endpoint. And then within the CRDs and the extension CRD that could be configured by the network administrator within the DPU cluster, you will be able to provide those services. So that's why I think that we can provide the transparent IPsec and transparent TLS mesh networking completely independent of the main OpenShift or main OpenStack deployment. And honestly, I think about OpenShift, but I also think that we can also leverage DPUs for OpenStack. And so that's why I don't want to only limit to OpenShift network model, but also to have something a bit agnostic between those two, which hopefully, because they do have orthogonal requirements, we would be able to fulfill most, if not all, of the requirements, including the bare metal use case.
I'm not sure if you've seen the OpenStack integration that's already upstream for using DPUs. Have you seen the specs that went in around the Yoga timeframe for that?
Yes.
Oh, okay.
Yes, absolutely. I thought that or worked a bit on that, and indeed, that's one way of deploying and to leverage DPUs, but that's not the preferred way, because we all know that Kubernetes has a better leeway, and I think that the networking model and focusing on Kubernetes on the DPU as of today will be better. And focusing on that, really, I want to be completely agnostic to the workload that is actually running on the x86.
Can Dmitry, you share some links so we all can see what you're talking about?
Yeah, sure.
While you do so, yeah, sorry.
Yeah.
But I think the implementation in OpenStack is more for remote OVN, or it does not describe how you cannot leverage multiple functions, or I think it's really limited to one specific use case.
Yeah, definitely. On the current implementation in OpenStack, you can only offload Oven, and you cannot leverage the DPU for more than that, meaning that you cannot deploy a specific function and you cannot leverage the specific hardware running, available from the DPU.
Yeah, there is effectively a language or the control plane missing for that currently. Like you can use OVN for creating load balancers and other things.
I fully agree with you.
So
yes,
yeah. So
my concern is about third party and how do we host third party functions directly on those DPUs, and how do we expose those services to OpenStack? And with the current implementation, because we cannot extend Oven with a dynamic set of features. Let's say, yes, within the DPU, we are running this and that CNF. How do we extend the Oven API in order to do that?
Yeah, that's a good question. OVN is kind of focused on, up to kind of, if we're talking about load balancing, not L7. So
yes.
Whereas Kubernetes, as you said correctly, it's a lot of it is service centric. So you need L7 handling in that. So go ahead.
Yeah, no, that's really the main idea that I focus on, which is how do we expose those CNF through a standard model? How do we discover those new capabilities, and how do we deploy them, and so on and so forth. So that's why we came up with that proposal based only on Yang, and with that extensibility provided by Sysrepo or any other Yang data store.
Yeah.
Chris, I see some.
Yes?
I see some users of Kubernetes here in the call. If they can chime in, when I say users, people who are deploying Kubernetes day in, day out, and if they can chime in and opine on whether they would like a CNI, I mean, how glued they are to existing CNIs and willing to manage the DPU based network this way.
So until people are shy and taking their time, I just want to, without derailing the conversation, I just want to reiterate my question previously is from Chris and the other OpenShift developers, for example, right? I just want to really be crisp with my question. Do you think that as OpenShift developer that wants to run OpenShift inside the DPUs, do you see absolutely zero value by providing some kind of hardware abstraction SDK across all DPU vendors, so your life as OpenShift developer will be much easier instead of implementing different implementation per vendor, one for NVIDIA, one for Marvell, one for AMD Pensando? Do you see any kind of value of providing that an abstraction layer that can help the OpenShift developer to write once on top of some kind of library or abstraction that we can do instead of you implementing 5-6 different variations of the same controller?
Well, from my perspective, as soon as we are talking about running on top of ARM cores, we don't need basically any kind of abstraction. The real difficulty is the hardware access and the hardware SDKs. And so as soon as we're doing that, adding an abstraction layer, it never worked. If we look at OpenCL, it was meant to support multiple vendors with different compilers, but at the end of the day, it was always a specific flavor of kernel. Well, if we're talking about OpenCL, about kernel code, in order to leverage the hardware capabilities or to tune that proper application towards a specific DPU. So giving the leeway to developers to directly use that hardware and that vendor SDK seems the more simple approach. But that's my perspective, and I may be a bit biased because I've been bitten by that promise before. So
and also it could be a really specific acceleration, because also some common libraries as DPDK can be used already on multiple platforms. It could be like if you have a specific ASIC or a specific for specific vSwitch acceleration or layer 1 acceleration. Here it's really specific, because in DPU we could have from telco to AI. If you want to do metrics log analysis, it could be completely different acceleration. I
agree, but your DPDK is one good example. RTE flows, I don't know, a lot of those functions that can be really abstracted across the vendors, and maybe we have a better chance of actually achieving the commonality. And I understand, Chris, where you come from, but maybe because we don't have so much DPU vendors today, so we only need to come to a common base across maybe 5 companies, right? So it's not that huge of task like running on the servers, for example, and trying to commonize that abstractions.
Because I think we have 3 or at least 4 vendors. I think between NVIDIA, Intel, Marvell, Xilinx also was during the call, AMD. So I think at least we have a good number of vendors who can also contribute to this.
Yeah, and definitely. So on the external interface, if we go forward with that young model on the internal abstraction level, maybe we could build on the existing elements, which is DPDK indeed, because DPDK is not only limited to networking nowadays. It also provides the ability to access to GPUs, to baseband drivers, and so on and so forth. So maybe the internal abstraction level,
everything about crypto flooding also.
Yeah, absolutely.
So I just wanted to chime in to say that in terms of the API, the standard APIs, DevLink was immensely helpful to us when working on the OpenStack and OVN integration, because we could have something standard to work with when it comes to talking to the network controller for certain advanced things. And without that, we wouldn't have been able to implement something generic that would be upstreamable to a project like OpenStack. And I think the same would apply to Kubernetes. And to be honest with you, like it's difficult to agree on pushing something that doesn't rely on the standard API that might change even across the device families from the same vendor, let alone from multiple vendors. So from the developer perspective and like from the upstreaming perspective, I definitely see the value in having standard interfaces provided to higher level software that could utilize it. So again, I made an example of DevLink, but RTE-Flow was named as well. That's another useful interface for which we could also utilize if we wanted to provide a user space based approach as opposed to the
I didn't want to derail the conversation. I obviously understand the value for the northbound or outside facing APIs. I just wanted to maybe create a new thought process around whether we can also abstract internally inside the DPUs as well for those providers like either networking, OpenShift, or maybe security like F5 who wants to run firewall inside the DPU. So they also would like to have some kind of abstraction inside the DPU as well.
Yeah, I mean, to hit on your original question there, Boris, my experience so far, just dealing with OpenShift is it's been a struggle to get OpenShift on each of the DPUs. So maybe Red Hat has a view that what can OPI do to help them, right? So that it isn't such a battle to put OpenShift on each individual DPU.
No, but yeah, each OpenShift on each DPU, it's not linked at all with API. Anything is, you have new drivers, and it takes some time to get in Linux, Linux 3, and after it's in RHEL. And for Red Hat, everything is open source, everything is Linux. So it took a lot of time for to have just these devices booting with a classic Linux. And so I think we should dissociate the fact that Linux is running well, Kubernetes is running well, OpenShift is running well, and after how we integrate the application on Kubernetes, OpenShift on the DPU. On one thing, perhaps some feedback also that could explain part of this design is also that because we have done some experimentation with different design from our side, and one of the difficulty also of having some software on the host and some software running on the DPU is the life cycle of these two layers. So it's why here the API is really helping a lot to have an abstraction between the host and the DPU. It means that you have less problem of upgrade, for example, because if you take Calico and you say, I am running some Calico thing here and some other Calico here, you could have a support matrix of a different version of different components, but you will have to manage some life cycle of components. So adding some complexity for this. Also, other aspect that we are looking is because we are speaking of OVN control plane or control plane of the host and some control plane on the DPU. If you have some disaster recovery things, or if you have some problem in one of the two networks, like saying, for example, you are killing your management controllers for the infrastructure running on DPU, the DPU should still run and you still provide connectivity. So on here, I think this design is simple and also can fit with this different scenario of life cycle or scenario of failure inside the network. It's some consideration we are also looking.
I just always think, who are the users of those APIs, right? So Chris said the network administrator, right? So network administrator rarely configure those things manually, right? So they have already infrastructure automation, whether it's Ansible or whatever, to configure those cards. That's fine. So we need to be focused like who and how going to consume that. If we're talking about OpenShift, I share VPN concerns, like how can we make different CNI providers to adopt those APIs talked about, like NetConf, RESTConf, if they're not using that today? What will make them to converge or adopt it? Maybe we can use many of those CNIs, Vipin told me, have plugin models. So what does it mean? Do we as OPI community implement plugin model, OPI plugin in each and every CNI? And then in that plugin, we can implement whatever APIs we want. I'm not sure I understand exactly how can we integrate that.
I could expand on that one shortly after. Let's close on where Chris started. So this is a picture Dimitri shared the doc. I'm just like sharing it with everyone here. In this picture, you have DPU running all the oven stuff and OVS things and really trying to leverage the ASIC FPGA related capabilities here. So Chris, if you can explain where is the OpenConfig API is going to fit in here, because I don't see it. I mean, Oven controller is talking OVS APIs to, I mean, it talks OVS API, Oven southbound, northbound APIs, depending on where you look at it, to configure the data path. And you don't need yet another configuration if that's what you're wanting to use. Now, yet again, I'll go back and say that if as DPU vendors, we want to create a CNI which is different from what is being used by existing CNIs, it's perfect. We could define our APIs and go with it and use the PDK RTFlow underneath or something else. But in this picture, for example, you also mentioned, Chris, that we will be able to use existing CNIs as is to run on these DPUs. But what's the role of OpenConfig / RESTConf, NetConf APIs in that picture? Because each of these CNIs have their APIs that their users could use to configure all these objects that I was sharing here. So, I mean, yes, the CNI provides access to all the network functions and connectivity and various knobs, and there are global knobs and besides these objects, and their way of implementing these things, which works okay if all DPU needs is boot up a standard operating system and let them run their things on the card. So I understand that part, but what I'm still not able to grok is how is that relating to where is OpenConfig and RESTConf API sitting in this picture, or equivalent picture replace all this blob of this CNI with some other CNI. For example, let's say Calico were to run Felix and BGP here, let's say, instead of this.
Well, in that specific case with OpenStack, I would say that it's maybe even a bit simpler because we wouldn't even have to modify anything from OpenStack perspective for the basic use cases. Because from OpenStack perspective, they want to have layer 2 connectivity. So the existing SIOV ML2 plugin will just configure the virtual function and to access to the VNAND 32.
Correct. So Neutron will take care of that, and ML2 plugin will take care of that. I agree with you.
And then,
I think the same thing applies with Calico, with Cilium, and with OpenShift. Is where my argument really is that if we are using those CNIs, all you need is to be able to run those CNIs here and have whatever offload functions these CNIs offer. To go back to Boris's question, what is the data path acceleration API we want to commonize? If you don't want to commonize data path interface API and want to commonize RESTConf, NetConf layer APIs, then existing CNIs do a very good job in exposing all kinds of network functions for various deployment scenarios. So where is, again, let's ignore the OpenStack for a moment. Let's say if this were to be a Kubernetes deployment and a CNI were to run up the host instead of hypervisor up here. Again, I'm using this picture to have that discussion. But if you were to replace some of these components for Kubernetes with pick any CNI of the three, let's say you want to pick Cilium or Calico or OpenShift, how will that look? What is the role of RESTConf, NetConf API in that? That's where my question is.
The role of NetConf API is to configure the load balancer that would be running on the DPU. Because
But most of these CNIs do offer a way to have it completely working without the RESTConf NetConf API. So if I'm using, for
yes,
example,
but you do not have that specific access from the external and from the hypervisor, from the x86
oh
node.
well, I could have an OOB port to have CNI taking all these commands through OOB port, and as a CNI, basically as a CNI, I'm running an operator in Kubernetes cluster. You don't give commands to every node or every DPU. You give commands to the entire cluster to say, hey, this is what I need, and this is my load balancing configuration,
Yes,
and then depending on the
and then you
service
have a single
configuration.
point of failure.
No. There's no single point of failure because an operator by definition can restart itself in Kubernetes cluster. Single point of failure would be if you just have one instance that just, if it dies, the whole thing stops. I mean, I have looked at various CNIs and how they operate. They have a centralized component and they have per node component, and per node component could be the BGP daemon of Felix or something that Calico is running, or an agent that is implementing the CNI plugin interface that Kubernetes offer when a pod is started and stopped and all that. So regardless, there is no APIs that you configure it directly to the agent. Usually you can configure things, but regardless of whether you have API to agent or not, they have a way to implement load balancing today. They have a way to implement mirroring. They have a way to implement all these functions in shipping today. My question is, and to configure even BGP, for example, or encryption, or routing, or NATing, or IP pooling, or mirroring, or load balancing, including the service object, which is there in Kubernetes. What's the role of RESTConf NetConf API for those CNIs? Because they are perfectly working. If I can port that CNI here and have that CNI accessible to OOB port, then I have got it what I want from the CNI.
Yeah, indeed, you do have that CNI running on the GPU, but from the x86 node and from that specific cluster, how do you access and how do you ensure that that specific workload is not doing anything which wouldn't be allowed? What kind of airbag do you have on that point, and how do you interconnect those two clusters?
So when it comes to RBAC and if you're talking about the security groups,
not security groups. That's not even about security groups. I'm really talking about the RBAC on the API, because as soon as you have the two cluster interconnects, if you do not have any way to provide the proper RBAC on that object model.
Let me put it this way. I mean, Kubernetes has a very good RBAC built into it. I mean, a CNI, every Kubernetes object that is, including network policy and all these CRDs which are exposed through Kubernetes, actually, by the way, all these objects I'm showing are exposed to Kubernetes CRDs, which means you can have a perfectly granular RBAC on all these objects. Who can configure what the role of the individual is. And this is, again, putting myself into Kubernetes operator's shoes. If I'm a Kubernetes DevOps person, I would say, well, I already am using Kubernetes RBAC plugins. All I need is who can configure NAT versus NOT. There is roles and there are all these things defined in Kubernetes. So why are you saying that these APIs would not have RBAC?
Well, that's because we're talking with the assumption that the GPU will be running Kubernetes, but what if it just runs a
Oh, no, I'm not
Kubernetes?
assuming Kubernetes is run on DPU. I'm assuming that the user of a CNI is having that kind of, gating or what they call, the control on the APIs through API server, not through, you don't have to run Kubernetes on the node. Like, for example, in this case, I need not run anything. All I could do is port the CNI back down here and have it interact with the rest of the Kubernetes from here. Sure, and then expose VFs to the host, so there is practically no presence or very tiny presence on the host. That's understood.
And we're trying to kind of have that model agnostic from OpenStack here specifically, so that Kubernetes, for instance, use OVN in the same way. So that was the idea, to have it agnostic from a specific cloud management system.
Okay. Yeah. By the way, I'm showing OVS picture because that kind of mimicked what was going through some of the details what Chris was presenting. So I didn't mean to say it is just OpenStack here, but you're right, Dimitri. I mean, if we are trying to get to this one, then RBAC is controlled at the API layer, which is where a CNI exposes all this configuration through through Kubernetes RBAC layer. Having said that, I mean, like I said, I'm not saying what you're proposing is a bad idea. It's a good idea if there are takers for people who want to take advantage of this network-based CPU control, which the main dilemma I'm having is how does that align with today's CNIs? And I don't see it aligning with it, or rather, there's no role for that OpenConfig or RESTConf API in that layer. CNIs today, these CNIs that I have referenced before, and if you look at these APIs, they have a way to define these objects. They have a way to control who can configure what. They have a way to work it across the Kubernetes cluster. Then their APIs work on-prem, off-prem. They have users which have been using these things for at least few years. All these CNIs are at least 2 to 3, 4 years old minimum. The question really is, what's the role of RESTConf APIs? Now, if we want to define DPU-based CNI that brings out the best value of DPUs, let's do that. I'm not saying no to that, but let's not mix it with the fact that today's CNIs will work great with these OpenConfig APIs because there's no role for OpenConfig APIs in the model that is going to leverage today's CNIs.
Yeah, but today's CNIs are never going to be used completely as they are on a DPU. I mean, I think we're arguing about two different scenarios here, or two different use cases almost. One is the brownfield deployment scenario, where we take an existing CNI and deploy it on the DPU, and rely on OPI APIs to offer the VF plumbing into the pods.
Correct.
And I think that what Christoph is talking about, and Christoph, feel free to correct me, is more of a black box offload scenario, which would require, touching the existing CNIs or developing a new CNI that'll essentially allow you to define your Yang model for your router or switch or whatever the fabric is under the hood. Right. And that gets offloaded to the acceleration part.
Miriam, I'm with you. Count me in. I'll even contribute if that is the goal and that's what we want to do. I'm saying it's a good approach from DPU vendor's point of view. Absolutely, yes, because you are providing a way to bring the value of DPU out and that to the fullest, as opposed to just using this as an offload thing. Because you can do offloads without DPUs. You can do offloads with foundational NICs that has OVS offloads and all that stuff, where all this. A lot of these functions are running up on the host and all that. But again, I want to decouple the two. If we say that we are developing this because we believe this is going to be the best thing for user from the value of a DPU, let's do that. As long as we are not saying that existing CNIs could really leverage. So brownfield wise, if we agree that we are not getting brownfield leverage, I'm okay as long as we all agree that this is where we are. That's all.
Vipin, Miriam, and Christoph. So to make it real, maybe if we're talking about 3 different use cases, maybe what will help is to have 3 separate pictures that we can all see together and work on them separately and see which one is we prioritize first, second, and third. I think that because we throw in a lot of those use cases, so we're jumping between different topics.
Yeah. Absolutely. And actually, I'm glad you brought it up, Boris. Myself, Billy, and Donald actually put together a set of slides around what we think are the full set of use cases, potentially. Obviously, we love feedback on that, and we have to come in and show the wider group.
Yeah, that'll be very beneficial. That way we can also look at it from the standpoint of, do we need to develop new CNIs? Do we need to develop plugins? Which component, where would they sit? How would they work inside the DPU? How do they work outside the DPU? We can see how that all folds together.
If you want to send something ahead of time, Miriam, go ahead and send on Slack or email chat.
Sure. Yeah, no problem.
Then we can discuss.
And the other thing we'd like to broach is the subject of, layered APIs. I think I've been joining these calls for a few weeks now, and I kind of hear everybody talking about like one networking API is going to rule them all. But in reality, I think if you're to cater for the different styles of use cases that are there, you're going to have to offer entry points to APIs that are, some are lower level than others, some are higher level than others, depending on what people are actually interested in leveraging from a DPU,
Yeah, and we we kind of align with that. We've been trying to take a look at it from the API perspective, from the different cases where we're looking at cloud, where we're looking at enterprise, where we're looking at telco, those different pieces, and seeing how they align. But we agree that there's probably going to be different levels of entry points that we're going to have to feed into beyond that.
Yeah.
Yeah, I think.
Brilliant. And just the last thing I'd like to point out, because I had a mic failure when we were talking about the value of a common API for offloaded CNFs that want to take advantage of acceleration, absolutely 100%. You know, I think there's absolute value in doing that. I would just caution about going with something like a DPDK API, because let's say CNF doesn't use DPDK. You know, there's ones that are using standard Linux kernel networking. They should always also be able to take advantage of acceleration without having to touch too much of their existing, you know, application per se. But it will always be more fair to, you know, have something generic that everybody has to work through as a CNF developer, you know. But that would be my, you know,
Yeah,
common developer hat.
Yeah, we see the same difficulty when you look at DPDK, when you look at RTE flow and all of those, and then how they would tie in correctly and where those tie-in points would be. You know, would it be underneath of a CNI? And in cases, do we even need to touch them? And yeah, that's an agreement point, because you may be able to go through a different aspect of the SDK and get better performance.
Yeah, even if you consider something as simple as a QAT,
Yep.
or you can access it via kernel. Yeah. Anyway, yeah, for sure.
Agreed.
Okay.
I have one more thing to add. So there is a greenfield approach on, you know, developing this API and a CNI that is circling around DPU. But if we were to attack brownfield, that is what I think my some of the if we were to take advantage of accelerating and leveraging existing CNIs, how would that be? So if there is interest, we can talk about that, and that's what I was going to talk about. I can share the slides beforehand next meeting.
I think there's definitely interest in talking about that, Vipin, because we're going to have to deal with brownfield. And I think next week we should continue this discussion, at least on the Kubernetes and CNI topics, see where we can go from there.
Yeah,
Miriam-
there's a lot of people using existing CNIs for a reason, and I don't think we can convince them, at least up front, just to swap over to some DPU
Yeah.
CNI. They've chosen
Right.
for whatever reason the existing,
correct.
and we need to figure out how to make those work as is. And then if we have this awesome DPU CNI that's just the fastest ever, that would be the reason for them to switch. But they're not going to.
Yeah.
They have their reasons for using their CNI.
Of course, yeah.
need to make sure
That's
that
where
they
I
work.
think.
Yeah.
Yeah.
So I'm
Exactly.
agreeing with you, but yes. So.
Yeah, awesome.
And they're not going to switch until it's proven. So
Yeah,
Right.
yeah.
But we're hearing a lot of no, and I understand today was one of the best discussions we had so far, but we also need to focus what yes. Okay, so no, CNIs are not going to adopt our APIs, and we cannot change them, but what is the right direction? I'm still fuzzy about it. What should we do?
I agree with you. Now, what I think could potentially happen is, which is what Miriam was leading to with our slides, is that, you know, even if we have, okay, we take a brownfield and we get it to run down on DPU, there's smaller aspects that we can accelerate, like an encryption. So we have an OPI API that accelerates encryption a certain way, so that they can leverage pieces of it, that kind of like what Miriam was alluded to, the multi-layered. So we start with smaller pieces that they can encrypt, or they can leverage acceleration for?
Well, honestly, any API that we propose, we will need to do the proper integration, whatever the existing CNI we have. So that's why I think that if we come up with a solution which will answer to that open question, which is how do I expose my CNF running on the TPU, all existing customers who want to use TPUs will just jump in, because that's going to be the standard from our perspective. Because even if we propose another model or another kind of API which is not Yang-based, they will need still to create that CNI in order to interconnect properly with that TPU, don't they?
Yeah, I definitely agree that the existing approaches versus a completely different model, it's going to cause a lot of pain for customers because they'll have to migrate all of their automation and things like that. So yeah, and that's what we were kind of looking for when doing the OpenStack changes, is to make sure that it fits into the existing model. Maybe
the direction here is to take 5, 6, 7 CNIs and implement translation from all of them to something that is across GPU vendors. It's a lot of work on us, but in that case, they don't have to change anything, and we adopt ourselves to
that's exactly where I was going to have some thoughts on, Boris, on what APIs exist that we could try and plug into these CNIs. If we care about brownfield, again, I'm not saying that what Chris proposed is a bad idea. It's just that we need to find takers of that from the use case economic point of view. But if there is interest, I'm happy to talk about where those APIs cut themselves and what choices are there. With we can even examine some example interfaces and see how that looks like. And if we want to commonalize those interfaces from these CNIs to start implementing as an acceleration layer or as a more than offload layer, but that. Yeah, I know most of us are getting late for their next meeting as well. So
I really encourage people to come, like Red Hat did and Vipin, prepare some presentations. This was really good discussion today because we came prepared. We see some visual slides. I think it facilitated one of the best discussions we had in this call so far.
Definitely. Thank you, everyone.
I'll share my thoughts on brownfield CNIs on Slack.
All right. Great.
Thanks.
Thank you, everyone.
Thank you.
Thanks, folks. Bye-bye.